In this example, we are going to do one of the in-class problems that I assigned for today, and these problems are also the homework problems if you did not finish in class. So I'm going to just show the steps for number 2, worked out all the way. Problems for number 2, the function f of x is equal to 4x to the 4th minus 2x cubed plus 2. And I've given you an a value of 3 and an h value of 0.1. And in part A, I've said find f prime of x. Okay, using the f of x plus h expansion. Okay, I'll let you watch a previous video on how to do that. You will find that your answer for f prime of x, when you do the f of x plus h expansion, and you get all of your h terms together and you collect them, you will get 16x cubed minus 6x squared. That will be your derivative function right here. So when you do the expansion f of x plus h and collect everything that has an h in it, this is what you will find. Okay. So that is the answer for part A. And part B, you're trying to find the tangent line. The equation of the tangent line is y minus y1 equals m times x minus x1. The y1 value, this is the function evaluated at a. In this case, our a value is 3. And when you put 3 into the function, I think you get 272, but let me check that with my calculator over here. So I will go over here to my calculator. I will make my function. This is the software Maple, which we will be using in a little while. The function is 4 times x to the 4th power minus 2 times x cubed plus 2. There is the function, and I would like to find my function evaluated at 3. And we're also going to need f prime of 3. Right? So you can ask the computer to do this and hit enter. And looks like f of 3 is 272. And when you find f prime of a and you put 3 into your derivative function, that would be 16 times 3 cubed minus 6 times 3 squared. You will find that that comes out to be 378. So you have all the necessary pieces now. M, you know the slope, that's f prime of a. So now we know our tangent line is y minus 272 is equal to 378 times x minus 3. Okay. If you solve this for y, that would be 378x minus 3 times 378, and then you would add on 272 from the other side. So you will get 378x, and then we do this number over here. It would be 3 times 378, and then I would like to add on 272. And that comes out to be 1406, and it should have a minus sign on it. Okay, so here is your tangent line. When you solve for y, this is what we call the tangent line. Okay, and that was the answer to part B. Find the equation of the tangent line. Okay, now moving on to C. It is asking us for an approximation. Approximate f of a plus h. What that means in this problem, remember that a was equal to 3 and h was equal to 0.1. This was given. So what they're asking us to do is to find the function evaluated at 3 plus 0.1. they want us to approximate the function evaluated at 3.1. So how do we do that? The approximation formula is the function evaluated at 3 plus f prime of 3 times h, in this case, which is 0.1. Okay? So the function evaluated at 3.1 is approximately, our function evaluated at 3 was 272. You can see that right here. The function evaluated at 3 was 272. The derivative at 3 was 378, so plus 378 multiplied by 0.1. And this simplifies to 272 plus 37.8. And you add those two numbers together, you get 272 plus 37.8. And you get 309.8. Okay. So there is the approximate value of f of 3.1 is approximately 309.8. Okay. Okay, so that is the answer to part C. Part D is asking you to compare, to bring all these values together. So f of a plus h is the function evaluated at 3.1. What is that number exactly? You put 3.1 into the function evaluated at 3.1 comes out to be 311.82. Okay. The other problem asked us to find approximately the approximate value f of x plus h. That was what we found in the first part, 309.8. Okay. The other part asked you to find L of a plus h. Well, that means look at your line and put in 3.1 into the equation of your line. And you know you're on the right track if you get the same value. You should get the same value. So let's double check that. Let's make a line. I want to make a line. Okay, and we know that the equation of the line from this previous step right up here is 378x minus 1406. 378 times x minus 1406. And I want to put 3.1 into the equation of that line. And what is this giving me? Negative 234.2. So that does not look exactly correct because it's not 309.8. So let me double check something here. My line, did I do some wrong numbers up here? Let me double check my line formula. Oh, this is supposed to be added. Yes. Minus 3 and then this. So this is the incorrect, that's an incorrect number there. So let me fix it. 1406, it should be minus 3 times 378. And then I need to add on 272. So our line should be not minus 1406, but minus 862. And evaluating that line at 3.1 gives an answer of 309.8, which is what it was supposed to give. Okay. So that is the part of comparing f of a plus h, approximately f of a plus h, and L of a plus h. Okay. The last step on part E was for you to create a table of values, x, h, x plus h, f of x plus h, and approximately f of x plus h. Okay. And to do this in Excel. So for example, your x value would be 3 in this problem. Sorry, let me erase that. Your x value would be 3, your h value is 0.1, and 3.1 was where you were trying to find the approximation. So for example, you should then try some other values closer to 3.1. So if you were to try 3.09, that means h would be 0.01. Because when you add x and x plus h, you get 3.1. So your job was to find these numbers, f of x plus h. If you did this in Excel, you would find that this would be 311.82. And you would get 311.82 here. If you do this in Excel, you should get approximately f of x plus h, which would be 309.8, as we've shown above. Let's show the Excel for how to compute right here, this value. Let me get rid of this, and let me get rid of Maple, which we will do later. And let me bring up Excel here. Bring up Excel. So Excel is opening. Let me where's the zoom? Let me make this a little bigger. Let me make this so the numbers are a little bit bigger for you here. 200%. Okay. So, as I said, let's create an X column, an H column, an X plus H column, an F of X plus H, and an approximately f of x plus h. Okay. And so this was 3, 0.1. You add these two cells together, you would get this cell plus this cell, and that should be 3.1. And this was the value that we found. Our function was, sorry, what was our function? Our function was 4x to the 4th. Let's put this function into here. It would be 4 times my x value is, I'm trying to find f of x plus h, so my x plus h value is in the C cell. I want to put that to the 4th power, minus 2 times my x plus h value to the cubed power, and then plus 2. There's the 311, and then the approximation was equal to, right down here, there's our approximation formula. I wanted to put my x value into the function. So let's put the x value into the function, 4 times the x value to the 4th power, minus 2 times the x value cubed, plus 2. So that is only f, this piece right here is only the part that we just typed there, right? This, the part that we just typed right here is only f of a, okay? That's only here. We need to add on for the approximation f prime of a times h. So let's add on the f prime. The f prime was 16 times the x value cubed minus 6 times the x value squared, right? And then we need to multiply all of that term. We need to put all of that in parentheses. Need to put all of that in parentheses. and multiply that by the h value. And there's the 309.8. So now you're set up to change the values, take an x value, put an x value that's closer to the point where you're actually trying to approximate. So let's say 3.09. This h value has to be 0.01. You add these together. We can now drag our formulas down. Drag the formula. That up, drag the formula. So all those numbers should have been the same, and here is the difference. So now we can say that that right here, this box right here, is f of a plus f prime of a h when a is equal to 3.09. So you're getting a better approximation to this value the closer you take your starting point of interest to 3.1. Okay, so that is the end of the video. That is the end of kind of this example. Number 2 worked out all the way, and you should be able to compute the rest of the problems in a similar fashion.